Hi everyone, my name is Emily Black, and today I'll be presenting my joint work with Manish, Raghavan, and Solon Barocas on model multiplicity. A growing number of works in the literature have drawn attention to the fact that there are many models available for a given prediction task, which have equivalent accuracy, but often differ substantially in other properties, such as fairness, robustness, and interpretability, among others. Aspect of this behavior has been named many different things over the past several years, from the Rashomon effect back in 2001 to predictive multiplicity, leave one out unfairness, and underspecification more recently. In this paper, we attempt to unify our understanding of this phenomenon, including going into more detail on how it arises and its technical, legal, and policy consequences. We call this phenomenon of multiple models with equivalent performance existing for the same task model multiplicity. As we discuss in the main presentation, in order to get a better understanding of the sources and implications of model multiplicity, under the umbrella of this term, we distinguish between procedural and predictive multiplicity, referring to differences between equally accurate models' internals and predictions, respectively. A lot of work in the fact community takes advantage of this behavior, perhaps without even knowing it. The very goal of enforcing fairness constraints on a model with minimal accuracy costs is exploiting the existence of model multiplicity. However, this very property, which is so helpful to our community, also presents risks, namely potentially having arbitrary outcomes and explanations from models. And this points to a need to justify why a given model is chosen beyond accuracy alone. Model multiplicity can arise from various choices made during model development. For example, choices such as the data that goes into training, feature selection, what model type is used, and learning rule is used. All of these choices can result in slightly different models for the same task, which may have equivalent accuracy, but may differ quite substantially on other behaviors, i.e. model multiplicity. Evidence for model multiplicity is plentiful in the literature. Dong and Rudin, among others, show that models relying on different sets of features can reach the same accuracy. This falls under procedural multiplicity. Recent studies also provide evidence for predictive multiplicity. Marx et al., who introduced the term, focuses on its effects at the individual level, showing that equally accurate models can make different predictions for individuals, while Rodolfo et al. Have demonstrated its effects at the aggregate level, showing that equally accurate models can have different group fairness properties. Our contributions in this paper are as follows. First, we give a principled understanding of the relationships between model multiplicity, accuracy, and variance. And specifically, we show that model multiplicity can actually increase with accuracy. Secondly, we connect the technical and legal implications of model multiplicity through a case study of loan decisions and the laws governing them. We argue that model multiplicity may provide more power to the disparate impact doctrine by putting pressure on model developers to search the space of equally accurate models for those with the best fairness properties. Finally, we present some policy recommendations for taking advantage of model multiplicity while addressing the concerns that it raises. At a high level, our paper argues that model multiplicity gives us a lot of flexibility to choose between equally accurate models. And in fact, that this flexibility may even lead to legal pressure for companies to search the space of equally accurate models to find the one that is the least discriminatory. However, we also note that without acknowledgement of the fact that multiple equally accurate models exist for a given prediction task, models selected for a given prediction task on the basis of accuracy alone can result in arbitrary predictions, which may also be frowned upon by the law in certain contexts. So we present methods of selecting between equally accurate models for a given prediction task, which preserves justifiability. Thank you so much. Please read our paper for more.